Hi, this is Adrian from Live to Learn Academy, and today's video is a common concept that a lot of students struggle with, and it's how do you find a sine graph and a cos graph from the same graph. So this video, I'm going to show the easiest way in how to do these types of problems. If you're new to the channel, we post videos every day like this from Monday to Friday at 3 p.m. Eastern Time. And if you're somebody who's interested in tutoring, feel free to click the link in our description and our team would love to get in touch with you. But without further ado, let's get straight into it. So when you look at this function, right? One important thing to know is a sine function and a cos function look very, very similar. But there's a bunch of key factors that we need to know when evaluating this. So the first thing is we have to know some key equations. Okay? So there are some key equations and key characteristics, you can say, when it comes to these functions. The first thing is the amplitude. And the amplitude, some of you guys may know, is max minus min over 2. And the good thing about the amplitude is that it's going to be the same for the sine function and the same for the cos function. Okay, so the amplitude is always going to be the same. The second thing you want to know is what is the k value. So the k value follows this formula 2 pi over the period. Okay, 2 pi over the period. And in this case, the k value as well, similar to the amplitude, is going to be the same for sine x and cos x. And the last thing we also want to get is the c value, which is the axis of symmetry. Okay, so the c value, also known as the axis of symmetry, is going to be max plus min all over 2. And this as well is the same for sine x and cos x. So the first thing I want you guys to know is I want us to find the a value, the k value, and the c value because we know they're going to be the same for both. Now remember the parent functions, okay? The parent function of sine is going to look like this. A sine k x minus d plus c. And we're going to find out what a, k, and c are. And then we're going to do the same thing for the cos function, which is a cos k x minus d plus c. And we're going to apply the same a, k, and c values. So let's first find the a, k, and c values. The max, if I look at my equation, my max is actually happening at 1, and my min is happening at -8. So if I want to find the amplitude, I would just say the max, which is 1, minus the min, which is -8, divided by 2. And what I would get here is I would get 4.5. Because 1 minus -8 is 9. 9 divided by 2 is 4.5. Actually, I made a mistake here. This is not -8. This is actually -9. So let me correct that for you guys over here, which will actually make our life easier because we don't have to deal with the decimal anymore. This is -9, so this would be 10 divided by 2, which is 5. Okay, so we found the amplitude. Let's find the k value. So the k value is 2 pi over the period. But what is the period? The period is the length of one cycle. So when I look at this graph, I want to know what the length of one cycle is. So the length of one cycle, the way I kind of look at it is I go from like a min to the next min, or I can go from the max to the next max. And that would be the period, the length of one cycle. So in this case, I can see it goes from 0 to pi, so my period is going to be pi. Therefore, it'll be 2 pi over pi, which is equal to 2, because the pi's cancel out. Okay, and there we have it. We have our k value. And the last thing we want to find is our c value, which is the axis of symmetry. So one way you could find the axis of symmetry is you're going to use the equation max plus min over 2. So max plus min over 2, which is -8 over 2, which is -4. That's one way we can find the axis of symmetry. The other way we can find the axis of symmetry is we could simply look at the graph because they provided the graph in the question, and we'll see right here that this over here is the axis of symmetry. And you want to think of the axis of symmetry as the equator. I like using this word, equator, right? Just how the Earth has an equator, the sine wave and the cos wave has an equator or a middle line that's called the axis of symmetry. So now that we know these things, the important thing we got to figure out is how we can apply that to this question. Because yeah, we found A, K, and C, but the one thing we didn't find, and a lot of you guys may be wondering, what is the D value? Okay, so remember, the D value in a sinusoidal equation represents the phase shift, okay? So when you have a sine graph and a cos graph, sometimes the graph may look more like a cos graph, sometimes it may look more like a sine graph. What you're gonna do is when you find one of them, you're gonna use the phase shift to find the other. So when I look at my graph, if I look at this graph, what I see visually from my eyes is I see something like this, which is a negative cos graph. That's kind of what I see off the bat. And the reason why I see that off the bat is I want to find out what graph corresponds with the y-axis, right? Notice I could also look at this cycle and say, okay, this is also a positive cos graph. But the reason I wouldn't choose this is because it doesn't correspond with the y-axis. So it's not that it's the wrong choice, it's just not an ideal choice when we're doing these types of questions. You want to see what corresponds to the y-axis. So when I look at this as my negative cos graph, I can really say that there's no phase shift because I chose the cos graph, so there's no phase shift. And the reason there's no phase shift is because I aligned it with my y-axis. Because the phase shift is how far away from the y-axis it is. So there's no phase shift. So therefore, I can write this equation, this cos equation, I can write it as y equals 5 cos 2x, right? Because there's going to be no d value. It's going to be 0. Minus 4 as my c value. But because it's a negative cos graph, I'm going to apply that negative, and this is really important. A lot of people don't mess this up. I'm going to apply the negative to the amplitude, right? Because I know it's a negative cos graph based off how I drew it up here. So that would be the cos function. But the second part is saying, okay, we can find the cos function, but how does the sine function look like? Now this is really important, right? The sine function, remember, cos functions look like this. And I just want to do a quick little lesson over here. There's a difference between a sine x function and a cos x function generally. A sine x function looks like this, and a cos x function looks like this. Now, obviously, these are the positive versions. The negative version could look like this, and the negative version can look like this. But something important to note is that with the sine x function, it starts at the axis of symmetry. You see how the sine x function actually starts at the axis of symmetry. But the cos x function is a little different. It starts at the max or the min. Depending on if you're talking about a positive or negative, it could start here or here. So this is very interesting. So now, how do I look at this graph and find the sine function? I would look at this graph and I would say, okay, you know what? The sine function starts at the axis of symmetry, so it's actually going to start here, and it's going to go and end here. So the green graph is the cos function, the purple graph is the sine function. But the problem is that because I started the sine function here, there's a certain level of phase shift that this sine function experiences. And this is what we call the phase shift. Okay, and this is where that d value is going to come into play for the sine function. So our question that we have to ask ourselves is, how can we find that d value? Okay, now I want you guys to understand the anatomy of this function. Okay, and when I say anatomy, I want you to just really understand this in a very simple way, and I'm going to break it down. When you see a function that's a sine function, it could be sine or cos. The sine function or the cos function is divided into 4 main parts. okay? This is going to be one section, another section, another section, and another section. So look at this. You're going to have one section here, one section here, one section here, and one section here. So the anatomy of the sine function is divided into 4 parts, okay? And if I want to find the length of each part, all I have to do is I just have to take the period and divide it by 4. And that will give me what this term is right here. So when you understand the anatomy of the function, it becomes super easy. So I already know that the period is 2. So if I want to find the phase shift, I would just say it's 2, which is the period, which is pi. It's period divided by 4. So the period is pi, and I divide it by 4. So my phase shift is actually going to be pi over 4. And because I started at the axis of symmetry and I went up first, I know it's a positive sine function. So taking all of this information and putting it together, the a value is going to be 5, as we know because we already had it here. Sine. The k value is going to be 2. The x value is going to be the d value is going to be x minus pi over 4. And then the c value is going to be -4. So notice we were able to get a sine function from this graph. And we were also able to get a cos function from this graph. Just by looking visually. The only difference is that the cos function was a negative cos function, but the sine function was a positive sine function with a phase shift, right? So notice how this indicates a phase shift of pi over 4 to the right. So this is something that you guys have to, this is something you guys have to understand when you're doing these types of questions, because at the end of the day, you need to know, is it a positive sine graph? Is it a negative sine graph? Is it a positive cos graph? Is it a negative cos graph? And the main thing is you actually have to refer this in relation to the y-axis. So one of your graphs, whether it's sine or cos, is going to have no d value. But the other graph will have a d value depending on how much you made it shift. So if you found this video helpful on how to find the sine graph and cosine graph from the same function, feel free to drop a like, subscribe to the channel for more videos like this, and I'll see you guys in the next video.